So if nothing else, most of us remember SOHCAHTOA. Remember what that represents? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? There's other ways to remember that. The PCA version of it is some old horse caught another horse, something. I don't remember what that was. There was another one like that. The non-PCA version I'll repeat after I'm not recording the lesson because it's hippies and drugs. But, there's that. That's what my teacher taught me. So on this one, any basic triangle here. Okay, I'm drawing a triangle in here for you, and I need that to be a nice one there. We're going to use that to just set up your basic sine, cosine, tangent here. Any triangle that you draw on the coordinate plane, you're going out to the side x, up, y, and we're just calling the hypotenuse r just for the sake of having it as a number. It's like the radius of a circle, okay? I am going to fill in my sine, cosine, tangents next to this picture so that I don't have to erase them. You are going to fill them into the box below. So if you remember, when you set up sine of the angle, you said that's represented by opposite over hypotenuse from the OH there, right? In this triangle, given that this is our angle theta here, what is the opposite side from theta? Y. Over R. We're going to set up the same thing for cosine. You're writing these down in your boxes below. I'm just not because I want to keep that picture. Cosine is adjacent over hypotenuse. In this case, in that picture, that is what over what? X over R. And tangent is what over what? Y over X. So you can use these representations. You can use opposite, hypotenuse, all of the ones that we've already learned. Either one's fine. Most of us have seen sine, cosine, tangent. We have not, however, seen cosecant, secant, and cotangent. These are what we call the reciprocal identities because they are reciprocals of the ones that are next to them. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and so on. Your abbreviations for them, you may want to write these down so that you know. Cosecant is CSC. If it is the reciprocal of sine, and sine is y over r, what is cosecant? R over y. Super difficult. Secant, SEC. It's the reciprocal of cosine, which makes it what? R over x. And last but not least, cotangent is COT. It would then be x over y. Just for memory for yourself, to know which one is the reciprocal of which, the first thing you need to remember is that the tangents go together. Tangent and cotangent, always. The other four, which ones go together, they cannot start with the same letter. So sine can't go with secant. Sine has to go with cosecant. Cosine can't go with cosecant. It has to go with secant. And that's generally how I remember them. So we're going to start just setting up sine, cosine, tangent on the back page here. Not super difficult. Flip to the back. If you are given any point, remember this is the xy coordinate plane. So if I'm given the point 6, 8, where do I go to get to the point 6, 8? From the middle I go, okay, right 6 and up 8. There is my triangle. Now I'm going to say this now because it always happens. You want your triangle to be set up like a reference angle. Okay, we've talked about reference angles already, but you want it to be set up along the x-axis. I say that because someone will always set it up, and you don't have to draw this. Someone will always set up your triangle up 8 and then right 6, and there's your triangle. You're going to get the same sine, cosines, and tangents, or you're going to get the same sides of the triangle, but you're looking from a different angle. And that's not what we want. We want to be looking from the reference angle. So this is our theta. It's in your corner down by 0, 0. It's a terrible theta. And we're going to use that to set up our sine, cosine, tangent. Before we can do that, though, what side are we missing? Hypotenuse. Anyone remember? This is the one thing I asked you to remember from geometry. A squared plus b squared equals c squared. Pythagorean theorem. Also, you can remember Pythagorean triples. 6, 8, what? 10. Just like 3, 4, 5 is a Pythagorean triple. Now, this math Not real difficult here. Sine. Your sine setup is opposite over hypotenuse. From theta, what are those two numbers?
8 over 10.
Okay, 8 over 10, which we reduce to 4 over 5. Cosine is adjacent over hypotenuse. What is that? 6 over 10, which we reduce to 3. Oh, we're not even finding the angle. We're just setting it up. I told you math is not real hard right now.
Okay.
Tangent. Yeah, don't get too complicated into this. We're just setting these up. Tangent is opposite over adjacent, 8 over 6, which reduces to 4 over 3. Carson doesn't even want to answer anymore. That's okay. All right, then we're going to do the 3 reciprocal ones. You'll notice that I typically line these up next to the ones that they go with to kind of help my own brain. That's just what I do. But these should be super easy because they're just the reciprocals of the ones next to them, right? So cosecant is 5 over 4. Secant is 5 over 3. Cotangent is 3 over 4. No rocket science here, right? These questions are actually worth quite a few points typically because there's so many answers to them. The one caution that I will usually say on these is some people will decide they do not have to draw the picture for it. If you happen to do that, that is up to you. It is, however, 2 out of this would probably be an 8-point question. 6 points for the answers, 2 points for the picture. I say that because the picture, you really have to have it in the right quadrant to have the right degrees and to have the right positives and negatives. So if you don't draw it in the right quadrant, it's fine. It doesn't mean you don't know what you're doing at all. It just means you screwed something up. Well, partial credit, if you at least draw your picture here, I can give you partial credit, right? Because what I'll do is I'll look at the picture and first just say, did you do the picture right? If you did the picture right, there's your 2 points for that. Then I go look at your answers. If you didn't, I take off the 2 points for the picture and then grade your answers based off of the picture that you drew. So that really can help you in an 8-point question. All right? Now, for question 2, same setup, and you're going to find out something really nice about trig here that we don't actually care about. If I'm given the point -4 positive root 2, again, it doesn't matter if you know what root 2 is as a number. It just tells you what quadrant we're in. -4 means I first go which way? Left 4, and then up root 2, whatever that is. All that really matters is that it's in the second quadrant. Here's my theta, -4, positive root 2. Again, what do we do to get our hypotenuse? Pythagorean theorem. Remember, just a couple pointers with this. When you square a negative, it makes it what? Positive. And when you square a square root, what does it do? Cancels out the square root. So that makes that 16 plus 2. So I'm going to simplify to get my hypotenuse, the square root of 18, which is 3 root 2. You do have to simplify those, if you can. There is something very specific that you're not going to have to simplify here in a minute. Okay? So let's just set up the one to begin with. Sine is opposite over hypotenuse. So I'm going to set it up as what over what? Root 2 over 3 root 2. Now, here, this is pretty common simplifying. What happens to my root 2's top and bottom? They cancel. So what's my answer for sine? 1 over 3. Please do some basic simplifying like that. What you're not going to have to do is the next one. Cosine. Adjacent over hypotenuse would be -4 over 3 root 2. In the past, what have I made you do with this? Multiply the root 2 top and bottom so you don't end up with a square root on the bottom. We don't care about that in calculus, in trig stuff, which means you may leave your answer like this. Okay? We're going to talk about it in a minute that you don't have to do that to all your answers, but you should still understand what to do if, let's say, a standardized test had a different looking answer than you. Okay? So still understand that, you can get that answer. That's fine. I don't care in this class. However, if that question was on the ACT, they would not leave it that way. Okay? So still remember the process of multiplying by root 2, root 2. Okay? Tangent is what over what? Square root 2 over negative 4. And how do we get the other 3? Flip them. So take a minute, do that on your paper. And we are not going to do the next page today. We are, however, going to go back and work on our charts, etc. What I would like for us to do, if I could remember the page number, is flip over to
It's cosecant, secant, and what's the last one called?
cotangent.
So the abbreviation COT?
Yep. We're going to flip over in our notebooks to page 26, which is just flipping over one page. All right. We're going to get there in just a second. In a 45, 45, 90 triangle, here were the sides. Okay. This is on question 2 here. The hypotenuse was 1. And these were the 2 other sides. Okay. Again, that's not something I'm like going through the process of how, because I don't think you care about that at this point. That's just what you learned in geometry. Okay. Now, using what we just talked about, okay, from that 45-degree angle, we said sine is represented by opposite over hypotenuse. Well, if I take the opposite side and divide by the hypotenuse, what do I get? Root 2 over 2. Okay, because I take that and divide by 1. Right? Now, look at your chart. Under sine of 45 degrees, what do you see? Root 2 over 2. Right? And to find the cosine, you're doing the adjacent divided by the hypotenuse. I'm going to get the exact same thing back out. If I look at my chart, what do I see it? Under 45 degrees, cosine. Root 2 over 2. If I would like to find the tangent using this triangle, I'm going to do opposite over adjacent. When I divide those two things, what am I going to get? 1. If you look under 45 degrees at tangent, you also have 1. So that is where these numbers are coming from, these special right triangles. At some point, we set those up and we solved them, and that's where we got the numbers in our chart. Okay? I show you that like one time because we're never going to do that again. We're going to just memorize them. How do you find the other 3? Flip it. So cosecant, 2 over root 2. Same thing for secant. What is the reciprocal of 1? 1. Now, again, I told you on things like cosecant and secant here, you don't have to fix those. But let's just say you're dealing with something like this on the ACT. They're not going to put an answer like that on there. So just like real quick review, the way you fix these answers is by multiplying by root 2 top and bottom. That would give me 2 root 2 over what? 2. What happens to my 2's top and bottom? They cancel. So what you would see on the ACT or something like that would be more like root 2. Those are the same things, and they got that by just fixing it. Okay, I'm not going to make you do that at this point because we're going to do a million of these answers. But if you have to, you all still can, right? That's just what it is. Now I'm going to show you the 30, 60, 91 on the next page, and then we're going to use the charts for what they're meant for. All right? I'm only going to show you the 30-degree one because the 60-degree one is the exact same thing, just flipped. So just so you know, this is where they both come from. So my 30, 60, 90 triangle, if you don't remember those rules, the long side was 1, the short side was 1/2, and the other part was root 3 over 2. So it works the same way. If I was setting up the sine value of 30 degrees, I would say, all right, what's the opposite? Well, 1/2 divided by the hypotenuse of 1 is just 1/2. Again, in your chart, under 30 degrees, if you look at sine, you do see 1/2, and so on. Cosine is root 3 over 2. Tangent, remember, when you divide this by this, again, going over this, we did this in the chart, but if you divide two fractions that have the same denominator, what can we do? Ignore the denominator, and you're just dividing one by root 3. And how do I get the other 3? Flip. So 2 over root 3 and root 3. Same thing for 60, only they just flip-flop because the angle changed. Again, we're not going to repeat that again at this point, but we are just going to use the chart for what it's meant for. So for a minute, we're going to take a break from our notebooks here. I am going to put the unit circle up on the board for you so that you can see it. Not that you need to have it memorized right now, but just so you can visually see what's going on here. And we're going to work through another page of finding sine, cosine, tangent values right now. And this is really where we're just going to finish up for today. All right. This is going to look just slightly overwhelming at the beginning here, but we're going to get through this pretty quickly. All right? Okay, so here's the 2 things you need right now. You need your filled out chart that we already did, and you need this paper that I just handed you. Okay? Now, some of these questions on the paper that I handed to you, you're already going to be able to do. For example, the first one on the top left. If I ask you for the sine at pi over 4, where can we look? The chart. You have a spot that says pi over 4. Go underneath pi over 4. What does it say the sine value is? Root 2 over 2. Same type of thing with the one next to it. Tangent at pi over 4. Go to pi over 4 in your chart. Go down to tangent. Write down the number you see there, which happens to be 1. All right. I'm going to skip down the paper. The next one that we can see directly out of our chart, under the second section where it's labeled question number 1, we should be able to do the sine at pi over 2, right? If I'd like to find the sine at pi over 2, where can I look? In the chart. You go to 90 degrees or pi over 2. You look at what's the sine value there. You write it down as, what's the number? What's the sine at pi over 2? 1. Sine at pi over 2? Ah. Okay. So then the other one that you can do right now is number 2 under the bottom half right here. So this question 2 right here. Tangent at pi over 3. You're looking at pi over 3 in your chart. Tangent value is?
Square root of 3.
Square root of 3. Okay. So those are the obvious ones, right? Because those are the ones directly out of our chart. The other ones are not as obvious. Okay. So let's all look back up at the top right one. Cosine of 150. Okay. Cosine at 150, we're going to get this based off of both the chart and the reference angle using the unit circle. I am not asking you to draw a unit circle and label it for everything, okay? As you get better at this, you will have kind of a mental picture of it, and it will make a little bit more sense to you. But that's why I have it up here so everyone can just kind of take a look at this as you're working, all right? So let's just think through the cosine at 150. The first thing that I would do is say, all right, where's 150? Okay. It's in what quadrant? The second quadrant, and it's pretty close to what? 180. Okay, in fact, it is this right here. Oops, that's still the line. That's 150. Okay? 150 has a reference angle. We talked about how to find reference angles last class. Its reference angle is between that and the closest x-axis, which is 180 right here. Therefore, what is the reference angle? 30. The reason that I say what is the reference angle is because the numbers at the top of your chart are the angles in the first quadrant, the first 5. They're also every reference angle throughout the entire unit circle. So when I realize that cosine of 150, the reference angle is 30, that means I pick up my chart and I look under 30 degrees because that is the reference angle that goes with 150. Under 30 degrees, what is the cosine value? Root 3 over 2. That is almost your answer for the third question. And I say almost, the rest of it's the easy part. Okay? The last thing you have to consider is the quadrants. Okay? And I'm going to teach you a little word phrase here that's going to help you know which one's which.
All students take time calculus.
Yes. All students take calculus. Not a true statement, but we're going to use it. Okay? The first letter in each of those words tells you in which quadrant these things are positive. Okay? And by that, I mean this. All. Literally all of them are positive. Sine is positive, cosine is positive, tangent is positive. The S in students implies that in quadrant 2, sine is positive, therefore cosine and tangent are what? Negative. The T in take tells me which one is positive? Tangent is positive, and therefore sine and cosine are negative. The C in calculus tells me cosine is what? Positive, and therefore sine is negative and tangent is negative. Now, we're not going to do a whole lot with the 3 reciprocal ones, but the reciprocal ones, not today at least, next class we will. The reciprocal ones go with the ones that they go with. So if sine is positive, so is its reciprocal. If cosine's negative, so is its reciprocal. So when I said root 3 over 2 is almost your answer, all I meant was that you have to consider 150 is in the second quadrant, and in the second quadrant, cosine is what? Negative. So your final answer for that third question on the top row is negative root 3 over 2. Now, that took a whole lot longer than you're going to take on the rest of these questions. Okay? It's going to start going quicker. But that's the reason I print out pages like I handed to you, because it just takes a little bit of practice. Okay? So let's everyone look at the second row, first question. Second row, first question on that page is sine at what? 240. All right, so my first question to myself would be, where is 240? Which quadrant? Third quadrant. And 240 is a little bit closer to this 270 down here. So 240 is actually going to be right here. However, what part am I going to use to find the reference angle that I'm going to use? The x-axis. So in degrees, you are always going to compare your angle to either 180 or 360, right? You're never going to use the 270 and the 90. So what would be the reference angle here for 240 degrees? 60. That means I look at my chart under 60 degrees and ask myself, what is the sine at 60 degrees? Root 3 over 2. In that third quadrant, should sine be positive or negative? Negative. So my answer to that question is also negative root 3 over 2. Okay? Now, one more degree, and I'm going to show you a radian one, because the radian ones, we already kind of talked about the reference angle thing, but it is easier to do that in a certain way. Tangent at 210. Where's 210 in my unit circle here? 210 is third quadrant right here, close to 180. What's the reference angle for 210? 30 degrees, because it's only 30 degrees away from 180. So that means when I'm asked for the tangent at 210, I go to the 30-degree reference angle in my chart, and I ask myself, what is the tangent there? What is it?
1 over square root of 3.
Okay, so then the last question I ask myself is, in that quadrant, is tangent positive or negative? Positive. So I leave my answer positive. Now, the trick to the reference angles for the radians. The denominator tells you what the reference angle is. So on that third one on the second row, when it says tangent at 7 pi over 6, I need to know what quadrant 7 pi over 6 is, but the reference angle is automatically pi over 6. Automatically, because the denominators must be the same. So on something then like the next question, when it says 5 pi over 4, the reference angle must be pi over 4. So that makes it very easy for us to find those reference angles. 7 pi over 6, going back to that one, the sine at 7 pi over 6, where would 7 pi over 6 be in my unit circle here? Third quadrant, because it's a little bit larger than 1, because remember this was 1 pi, this was 2 pi, and this was 3 pi over 2, and pi over 2. Okay, so 7 pi over 6 is actually this one right here. I only really need to know that it's in the third quadrant, so that when I say, okay, what's the sine at 7 pi over 6? I know the reference angle I'm going to use is pi over 6 because it has the same denominator. I go to pi over 6, I look at what is the sine there, which is 1/2. And in the third quadrant is sine positive or negative? It's negative, right?
Negative.
So my answer to that third one there is negative 1/2. All right? Now, here's the thing with that. I can tell you and go through those one at a time with you all I want, but until you actually sit there and do them yourself, it's just going to be a process, right? So what we're going to do really is just spend time practicing here. Okay?